HoloEdit assumes volumetric video is captured and edited at a 30 frames per second animation rate. When working in combination with HoloEdit, it's important to ensure that the frame rate for the scene is set to 30. If you have the timeline set to a different frame rate, you will see issues on import or export of your animation FBX. You can change the frame rate in the time slider options of the preference window, or below the play options in the default Maya timeline setup. For this tutorial, we've provided a Maya scene with some additional content. We'll open the Maya scene named Baked Performance Editing, starting workspace now. You'll see that this scene contains the punching bag we want our boxer to interact with and some markers we've placed to plan out the animation. Now that we've prepared our scene, we'll import the volumetric video clip that we exported from HoloEdit and begin editing the performance. In the File menu, select Import and import the Baked Editing FBX from the Baked Performance Export folder we created. The FBX contains material for each frame's corresponding textures. We'll enable hardware textures in the shading menu to display them, and set the lighting mode to use flat lighting. Next, we will use the Merge Vertices tool to ensure that each frame of our mesh is one continuous surface in Maya. It's necessary to merge the mesh to allow for smooth skin weight painting. After merging, we'll clear the object history by selecting Delete All by Type in the Edit menu and choosing History. After importing the clip, we can scrub through the timeline to view the mesh data play back. Each mesh is keyed for visibility on the corresponding frame. Next, we'll skin weight the mesh to the animated skeleton imported with the FBX. It's important that you're on the first frame of the timeline when you select the Generate Skin Weights tool. Use the Gen Skin button in the HoloSuite shelf to generate automatic skin weights. Once the script finishes running, each mesh will be weighted to the skeleton. Our plan for this edit is to take the kickboxer performance and modify the shadow boxing animation to make some direct interaction with the punching bag. If we play through the clip with the punching bag in place, you can see some of the strikes don't make a direct connection. And since the actor wasn't originally intending to hit a bag, some of the strikes lack the force you'd expect. Additionally, in the last 50 frames, the actor pivots away from the location of the bag. We'll want to adjust her punches to better match the bag, and modify her motion to keep her oriented towards the bag for the whole clip. Using our imported skeleton and an animation layer, we'll make adjustments directly to the joints and animate as if we were using any other FK rig. We'll create a new animation layer in the Anim tab and add the whole skeleton to the animation layer. Since the skeleton has been combined into one asset for the whole sequence, we could build a rig and apply it, but because the length of the bones adjusts slightly frame to frame, we would require some additional engineering to get a control rig set up. For now, since it's for a short, quick sequence, and many of the adjustments are minor, we'll go ahead and make the changes directly to the skeleton. Let's watch through the clip again and review our planned edits. Starting around frame 70 to 100, we'll adjust the punches. The first jab already roughly connects with the bag, but we'll adjust the shoulder and arm a bit to make a more solid connection. The second right jab is a bit off center, so we'll move that to connect more solidly with the bag, and also add a bit of movement to the bag as well in response to the hits. The left uppercut is pretty close to connecting with the bag, so we'll adjust the shoulders just a bit to make sure this hit feels powerful. The biggest adjustment for this clip we'll be making is reorienting the pivot away from the bag the boxer makes. We'll want to keep her facing the bag and allow the second sequence of strikes to hit the bag. With our skeleton and mesh imported, we're ready to go. Something to keep in mind is the current skin weighting on our mesh has been generated automatically in Maya, and there may be some inaccuracies. Anything that we're not directly editing should be fine, but it's worth taking a quick look at some areas we know we'll be adjusting. We'll start by taking a look at the weights for the first sequence, frames 70 to 100. Access the Rigging menu, select the Skin File menu, and select the Options box for Paint Skin Weights. To quickly navigate the timeline and mesh selections, use Alt + greater than or less than to step forward and back on the timeline, and the left and right arrow keys to navigate through the mesh selections in the outliner. Taking a bit of time to review the skin weights can let you know if there are any issues before you start the process of animation. After taking a quick look, there's a bit of crossover from the arms to the torso in the first 100 frames, but it's pretty insignificant and not likely to affect the changes we'll be making to the animation. Because a lot of the auto-generated skin weights are actually quite good for the first 100 frames of our edits, we probably won't have to make any heavy adjustments. So we can start our animations and keep an eye out for any weights that look like they will be troublesome. One adjustment we will want to make before we start our animation is the head. We'll be adjusting the angle of the head and eyeline throughout, and we want to make sure that we have 100% of the mesh's head following the head joint. If we try to reorient the head with the automatic skin weighting, you can see that the chin and neck warp pretty significantly. We'll correct these skin weights manually. We can start on frame 0, so we'll use the outliner to select the first frame of the sequence, then access the Paint Skin Weight tool options and select the head joint. We'll use Maya's Paint Skin Weights tool to adjust the skin weights accordingly. Let's take a look at how this deforms by rotating the head joint now. This looks good. We have a pretty smooth blend all around and a pretty natural feel to the adjustments we make. We'll get our rotations back where they were and open up the Skin Weight Transform tool to propagate these edits. Press the Skin Weight Transfer button in the HoloSuite toolbar. We'll leave the first field at 0 since that's where we painted our skin weights, and set the second field to 175. Select Run and give it a minute to process. We can now jump as far as the end of our sequence and see that the head weighting adjustments have carried throughout all of the frames. This tool will have varying success depending on the level of detail and amount of segments you have in a clip. For a large and rather flexible adjustment like this, it works exceptionally well over the transition of 176 frames and 10 segments. Finer details are more likely to soften and blend if transferring across multiple segments, and it may require you paint and transfer from multiple frames throughout the clip. As a quick example of this loss of precision, let's jump back to frame 0 and select the root joint. Then add a nice big smiley face to the kickboxer's back. Run the Skin Weight Transfer tool for the whole sequence and take a look at the results on frame 175. As you can see, there's a fuzzy resemblance to the skin weighting we applied, but quite a lot of precision has been lost. Compared to frame 77, which is still in the same segment, you can see a perfect replication jumping a few frames ahead past the segments line. You can see the softening of the results. Let's undo those changes and get back to editing our clip. Now that we've got skin weights that are good enough to get started, let's work on the first 100 frames. All we'll be doing with these frames is tweaking the punches to make sure they connect soundly with the bed. With the animation layer we created selected, we can make adjustments to the animations of the skeleton and change our actor's performance. We'll begin making adjustments on frame 65. For this demonstration, we'll start by adding a keyframe for all of the joints in the skeleton. So we'll add a keyframe to frame 65 with all of the joints in their original position. We'll start animating from the back joint. Make adjustments as needed to the torso, making the directional changes to make the kickboxer better aligned to the punching bag. We'll work to shoulders, then arms, making adjustments to the rotations of the joints as necessary. When we get to the final 75 frames, there will be a few more adjustments that have to be made to the skin weights. Starting at frame 100, we'll have to make sure that the root joint isn't controlling any of the skin weights, since the root is what we'll be using to redirect the steps and keep the kickboxer oriented towards the punching bag. We'll have to manually paint adjustments for the final 75 frames of the clip, as we'll be using the root joint to reposition the skeleton as we keep the boxer oriented towards the punching bag. Also, because we'll be making much heavier adjustments to the joints in the final 75 frames, we'll take the time to polish the skin weights for the whole skeleton. Once skin weighting is complete, we'll begin with adjusting the animation for the final 75 frames. As a bit of an aid, we can take note of the foot position markers we provided in the example scene to plan out the animation. We'll be reorienting the boxer by rotating and translating the root joint. To keep her rooted while still changing the position, we'll want to make sure we can keep the planted foot in the proper position. The more accurate we can be, the more convincing the change of action will be. With the foot position markers in place, we can see the desired targets for each step taken marked with L or R for left or right, and the number indicating the order that the steps are taken. We'll make note of when the feet are starting and ending a step, and make the adjustments to the root joint between those points. We'll start by rotating the root to get the angle that will get both feet in place for frame 110, and adjust the rotation and translation for each subsequent step. With the main movements to reorient the actor in place, we'll start to adjust the torso and arms to first tuck in and avoid hitting the bag as she moves past it, and then make the adjustments required to allow the jab to connect and line up the knee to make a solid contact with the bag. Additionally, we'll go through the sequence and animate the bag to respond to the hits. We'll save the Maya scene as baked performance editing _ completed animation. Now that we've made all of our performance adjustments, we're ready to export and bring the changes back into HoloEdit and generate an OMS. We'll start by merging down the animation layer we created to capture our edits. First, right-click on the animation layer and check out the merging options. You'll want to ensure that the results layer mode automatic is selected. Next, select the top layer, then the bottom layer, right-click and select Merge Layers. Once that finishes, we're ready to export our mesh. Since we don't plan on doing any dynamic retargeting, we only need to export the OBJs. We'll start by exporting our OBJs using the Export OBJ tool. Let's create a new folder for the OBJs. We'll call it baked_stream and select Save. If you encounter an error on export, verify in Windows, Settings and Preferences, Plugin Manager, Maya's built-in obj export.mll plugin is loaded. Next, we'll go back to our original export folder and select the textures that we exported originally. We'll copy the PNGs from that folder to our new folder. We can move back to HoloEdit to compress our clip using SSDR. Moving back to HoloEdit, we'll add the files we exported from Maya to our HoloEdit workspace. Next, in HoloEdit, we can import our updated performance as a new clip. Since our clip is still stabilized after our edits, we'll enable Detect Stabilization for our mesh and texture data. With the clip imported, we'll bring it in to create a new track. Let's take a minute in HoloEdit to compare the old version of the clip with the updated performance. For the first 65 frames, we didn't apply any edits to the performance. Moving forward, after frame 65, you can see that the punches start to diverge. The changes become much more evident in the final 75 frames, where we start to change the root motion of the kickboxer. Next, we'll add an SSDR stage to apply compression and prepare our clip for export. We'll create an interval spanning the whole clip and execute it. This will take a few minutes to process, so we'll jump ahead to when it's complete. Great! Now that SSDR has been applied, we're ready to export our track as an OMS. We'll select Export Composition from the File menu, export it to the same location we used before and add an OMS export step. We'll name our OMS Kickboxer, then select Save. Next, we'll add an MP4 step. We'll name this Kickboxer as well and leave the settings as they are and select Save. We can select Export now and wait for our OMS to be generated. With the OMS exported, we can save our HoloEdit composition, then bring everything into Unity to review our clip using the Unity OMS player. Thank you for watching this tutorial on baked performance editing using HoloEdit 2020.4 and the accompanying Maya plugins. In the next video, we'll set up our clip for playback, and you'll learn how to use the Unity timeline to sync animation with the OMS player and the punching bag animation.